Okay, we're going to carry on. Thomas is going to talk to us about the pitfalls of measuring network storage.
Well, can you hear me? All right, fine. Okay, I'm from 1&1, and probably you know that 1&1 is one of the largest web providers in Europe, if not the largest. And you can imagine if you have several 10,000s of servers, almost approaching the range of 100,000, then it matters which hardware do you buy, in particular storage hardware. So this talk is going about commercial versus open source. Commercial is clear. There are a number of vendors I will not name in this talk, and you will see why I will not name later. And open source in this context means that you have a Linux stack and software, and of course the hardware remains, and you need some hardware. And this is not open source, of course. Usually I'm comparing against a RAID controller, which is like hardware, also it has a firmware on it. Okay, I start with what's the main difference between blkreplay and usual tools. And then I come to the main point of this talk, artificial benchmarks and real-life benchmarks, which try to approximate the real-life behavior of applications. And that can make a difference, and I'll show you some example. It can be drastic differences. And, well, I have one pitfall which I will try to address, but there are many more pitfalls. You can create fake results, which will differ from real results by factors, if not by orders of magnitude, if you do the wrong things. So it's really, most results on the internet are faked, I think. And I have reasons to believe that. I'll show you some of them. Okay? It's just a short introduction what I want to talk about. Okay. blkreplay. Well, I created it as a byproduct. It's not. I'm currently working on Mars. That's asynchronous replication of the network, and this is just a byproduct. Because there's the problem that the usual benchmarks are artificial ones, and most of them are just overloading the system with random requests or whatever. So these are usually overloading benchmarks, and just looking what the system does with overload. But overload is not the only situation you want to know for practice. In practice, most systems are not overloaded all the time, but only in some peak situations. Okay? And it's very interesting to look at the difference between normal operating mode and what's happening at peaks. So there can be a very, very large difference. So one of the things you can do with blkreplay is just look at the normal operating mode. Just replay in the laboratory what's happening in real life, in your real life systems. Okay, and that means the positioning and timely behavior must be replayed, and also the I/O parallelism. It's very important that you have the same degree of parallelism as in the lab as you have in real life. And something which I haven't found in other tools is automation. If you have large projects and want to test several machines and several loads and do all that automatically, here's a test suite written in shell script, and with plugins you can enhance it or whatever you want. Okay, and probably the most interesting point for you could be the database of real-life loads, which have been measured at 1&1's data centers from different application areas, and some of our servers are loaded with 10,000s of customers, and others, of course, with less customers, but very interesting properties in this load. You can look at it. It's published under GPL and similar licenses on blkreplay.org. That's the only one thing you have to remember from this talk. Okay. Well, this is the first example. It's a random load, that means an artificial one, and it's ramping up. That means it starts with 1 IOPS per second at second number 1, 2 at second number 2, and so on. Just increasing the load until at some point the green line is the demand IOPS, and the orange line is the true actual reaction of the system. Okay, it's clear, can you read it? So this is some expected behavior that at some point performance will just remain at some limit. Okay. And about 800 IOPS. Do you think that's much or it's not good? What do you think? Well, the system is a RAID system with about S8 with about 50 spindles. And it's full random over the full disks. 50 spindles in parallel. It's not very good, yes? Okay, because storage vendors are claiming very different numbers. That's the next slide. Okay, this is a commercial system and it's a whole other world, you think, or don't you think? But if you look at the picture here, you will find something which is irritating. Are you irritated or not? Why isn't it stable? Why isn't it stable? Okay, that's 2,000, 3,000, 4,000 IOPS in the peak, whatever. That seems to be, okay, it's a clear winner or not. Is it really won by the commercial system or not? What do you think? Okay, I'll come to this. This is an artificial load. And now we turn to real benchmark of real world load. That means we have a server. Here the scenario is 25 virtual machines, a thin server in parallel, over iSCSI to one central storage box. Okay? 25 instances of blkreplay in parallel. And the load is from a natural one, but we have selected the peaks. Okay, that's also a kind of overload scenario, but from the real life. Not exactly random, but of course there's random parts of inside it. And it's recorded by block trace. You probably know it's already in the kernel, and there's already some tools around it. And okay, try it out. The blkreplay uses classical threads, classical processes, not IO. Okay. Now what's the result? Okay, this is our first system, classical RAID. There's a Linux stack on it. And oh, the numbers are very different from our random IO. What's happened here? Much higher. What do you think? Well, it's a property of the virtual machines. They are coalescing I/O in some way, buffering in cache, and then you get much more sequential I/O, but not true sequential I/O. So suddenly the S8 disks are better than you thought before. Yes, it's a property of the S8 disk. If I use other disks, for example the enterprise grade, the very fast and expensive ones, there's a different behavior, a very different behavior. But okay, it's interesting. And now what's with the commercial system? It's less. Okay, this is the first striking example what artificial benchmarks versus real-life benchmarks. Okay, is it really the true performance of the commercial system? No. There's even another problem, not yet present here. That's the next slide. Most commercial systems, and even some free ones, have a special layer which deals with storage virtualization. Okay, here's the basic principle how it works. You have, for example, 50 terabytes. Just as an example, 50 spindles, each 1 terabyte. So, and in this address space you are loading this random I/O, the first test we had. Okay, and this is translated to some physical address somewhere. And there are two strategies. The one is the pre-allocation, and the one is allocation on demand at runtime. In this case here is allocation at runtime, and usually the allocation strategy is just to allocate the next free block, so in sequence. And here you can see what happens. You are thinking you are benchmarking with random I/O, but in reality you have sequential I/O. So what do you get? You get fake results. In reality, you are not benchmarking the random behavior of your system, you are just benchmarking the effectiveness of the translation layer, the throughput of this layer. This is completely wrong. Okay, it's clear. And there's one countermeasure: just fill your logical volumes with some random data. Don't fill it with zero blocks, because some commercial black boxes, there are black boxes, might detect this, and maybe that I don't allocate anything. Maybe. It depends on the vendor. You can't see it. So just use random data and fill them. And okay, the next slide is with the fill. The first slide was the commercial system without filling it, and now the next slide I will show you is without filling. What do you think? What's the difference? Okay, here is it. Okay, usually your customers will fill your logical volumes with data. Okay, which one is the real performance? This one or the former one? Well, in reality, it's something in between, because it's not completely filled to 100%. Okay, it's clear, but it will come more close to this here, in reality. Okay, the winner is clear now, and the price is also clear. The commercial system is more expensive than if you build your own RAID system. Well, and if you have several thousands of instances, then it's clear what it makes in money. Several billions, maybe. Millions at least. Not billions, sorry. Okay, this is the headline of my talk, the bottom line. And this is just one of my last slides. Well, chances for open source stacks. This is the main discussion point here. One of the strengths of the commercial systems is they are dealing with big companies, and this is the main problem for open source solutions. They typically cannot compete in that area of manpower, of support, and of company size. Okay, but there's a chance if you find out the truth. I've written it in capital there. The truth is very different from advertising and from what salespeople are claiming. In some cases, not in any cases. But finding out the truth is something you have to do as a sysadmin. So just use the right tools and use the right methods to find out what is really going on, and you can save much money, a lot of money. Okay. And the next step is then your management. If you are working in a larger company, typically they are believing the salesperson, not you. So produce results on paper and show them what's really the truth, and tell them why these results are correct and the others are not correct. So this is my last slide. We have time? Yes? Okay. Well, this is the bottom line. Never trust any claim from anybody. In particular, claims from salespersons. Did you ever have to do with salespersons? Okay. But not storage salesperson, or also? Both. Okay. So you know what I'm talking about. Okay. It's all clear. Always check yourself. The bottom line here is a tool which hopefully will help you doing that. Thanks. Questions, okay? We're on time? Yes?
Anyone?
Well, I just